Looking for a soul opens a new unexplored door. Tune in and soar with us, let's flow. Discover the unknown, see where we go.
All right. Hey, everyone, get ready, because we are diving deep today into how AI systems talk to each other.
And especially when we're talking about these really complex AI systems.
Yeah, those large language models, or LLMs, like we always hear about.
Right. How can we get them to communicate more efficiently?
Exactly. And it's not just about one AI doing its thing. It's about how multiple AIs can work together, right?
Yeah, that's where these multi-agent LLM systems come in.
Okay, multi-agent systems.
So instead of just having one AI trying to solve a problem, you have a bunch of different AI agents.
Like a team of specialists.
Yeah, kind of like a software development team.
I like that analogy. So each AI has its own role.
Right. You might have one AI agent that's really good at writing code.
Okay.
And then you might have another one that's really good at testing that code and another one that's good at managing the whole project and keeping everything on track.
So it's like a well-oiled AI machine.
Exactly. But here's the thing.
Yeah. What's the catch?
Well, all these AI agents, they need to communicate with each other constantly, right?
That makes sense. They have to share information to work together.
Right. And that's where we run into a big problem, the communication bottleneck.
Bottleneck. Okay, I'm sensing a problem.
Yeah, think about it. These agents, they have to send each other massive amounts of information to stay in sync. And every time an agent receives information, it has to process it all from scratch.
So all that processing time adds up, like a traffic jam for information.
Yeah, you got it.
And this slowdown, it has a name, right? Something like pre-fill.
Yeah, the pre-fill phase.
And the sources said this pre-fill phase can take much longer than the AI actually generating a response. That seems kind of crazy.
It is. You would think the thinking part would be the slowest, but sometimes just getting all that information transferred and
It
processed.
beats up all the time.
It really does. It's like spending hours reading a textbook before you can even start working on the problems.
Okay, I'm starting to see the problem. The sources must have some real-world examples of how bad it can get.
They do. Imagine a system like MapCoder. Yeah, it's a system designed for tackling these complex coding challenges. In a system like that, you might have agents dealing with up to like 38,000 tokens of information.
Wow, 38,000. What does that even mean in like human terms?
Think of tokens as the basic building blocks of information that AI works with. So 38,000 tokens, that's like...
A lot.
Yeah.
Huge. So we've got these amazing multi-agent LLM systems that can potentially solve all sorts of problems, but they're stuck in this communication gridlock.
Exactly.
Not very efficient.
No. And that's where this research paper, DroidSpeak, comes in.
DroidSpeak. Okay, tell me everything.
So DroidSpeak tackles this problem head-on. Instead of making each agent recalculate everything from scratch, it focuses on reusing information that's already been processed.
Interesting. So less work, more speed.
Right.
Yeah.
The idea is to make communication as efficient as possible.
But how do they get these AI agents to, like, share their brain power?
Well, the key insight here is that when you have AI agents that are based on the same underlying model but fine-tuned for different tasks...
Like they're all from the same family, but they've specialized in different areas.
Exactly. Their thinking processes are actually remarkably similar.
Even though they're specialized, they have a lot in common.
Yeah. So DroidSpeak takes advantage of that shared understanding.
Okay, less reinventing the wheel, more building on what's already there.
Exactly. Imagine you're sending a friend a recipe, but you've already done half the prep work.
Okay, I like where this is going. So
Yeah.
they don't have to start from scratch.
Right. They can pick up where you left off and save a ton of time. That's what DroidSpeak is doing with these AI agents.
Got it. Less prep time, more cooking. But what kind of information are we talking about here?
So DroidSpeak focuses on reusing two main things. First, there's the KV cache. Think of it as a condensed summary of everything the AI has learned from the conversation so far.
Like the AI's personal notes on the topic.
Exactly.
That's saying, hey, I've already thought about this. Here are the key takeaways.
Right. And then there's the embedding cache or the eCache.
Okay, eCache. Got it.
And this represents how the AI initially understands the input text. Like it's turning words into a numerical code that the AI can process.
So if the KV cache is like the AI's notes, the eCache is like the raw data it's working with.
Yeah, that's a good way to think about it. Now you might think, why not just reuse everything from the KV cache? Wouldn't that be the fastest?
It seems logical. Just copy and paste the AI's notes.
But here's where things get interesting. Even though those fine-tuned models are similar...
They're not identical twins.
Right. So reusing the entire KV cache can actually lead to worse results because there are subtle differences in how they process information.
Like using someone else's notes might not always help you on a test.
Right. They might have a different understanding or a different way of organizing things.
So there's a trade-off then.
Yeah, speed versus accuracy.
So DroidSpeak can't just blindly reuse everything. It needs to be more strategic.
Exactly. And that's what makes it so clever. DroidSpeak focuses on reusing both the KV and E caches.
The best of both worlds.
Yeah, but it targets those layers of the model where the similarity between the two AI agents is highest.
So it's like figuring out which parts of the recipe are universal and which parts need tweaking based on your friend's preferences.
Exactly.
And the selective reuse, does it actually work?
It does. Figure 13 in the source material shows that reusing both KV and E caches in this way can lead to speed improvements of up to 2.78 times.
2.78 times faster. That's a huge difference.
It is. And the amazing thing is it does all this while maintaining almost the same level of accuracy.
So we're getting faster processing without sacrificing quality. This DroidSpeak system seems pretty impressive.
It is, and it could have big implications for how we design and build AI systems in the future.
I bet. So is there more to this story? Like, are there specific applications they're looking at for DroidSpeak?
Oh, absolutely. There's a lot more to explore. For example, imagine AI assistants that can collaborate on complex tasks in real time.
That would be amazing.
Things like writing creative content or developing software, all without those annoying communication delays.
Okay, now I'm really intrigued. Are there any other fascinating tidbits from the research that we should dive into?
There are. We need to look deeper at how this selective reuse works and understand why some AI pairings are more compatible than others.
It's like they have different levels of friendship.
Yeah, kinda.
All right, I'm ready to dive in. Let's unpack this AI buddy system.
Let's do it. Welcome back. We're digging deeper into DroidSpeak, and before we get to those AI pairings you mentioned.
The AI buddy system.
Right. Let's rewind a bit. Remember, DroidSpeak speeds up those conversations between different AI agents.
By reusing info they've already processed.
Exactly. But it's not just about making things faster. It's about understanding how these agents think.
And where their thought processes kind of line up, right?
Right, like how compatible their thinking is.
Okay, but how do researchers figure out what info to reuse? It's almost like they have to read the AI's mind.
Well, it is complex, but the researchers developed a system for this.
Okay, what's the secret sauce?
Remember that offline profiling we mentioned?
Kind of. Refresh my memory.
It's basically a test run before those AI agents go live.
Like a dress rehearsal for the AI.
Yeah. And during this offline profiling, the system analyzes how similar the two models are.
Like comparing their notes to see how much their understanding overlaps.
Exactly. So it's not just about the data they're sending, it's how they process it.
Their interpretation of the data.
Right. And this is where layer-wise optimization comes in.
Layer-wise optimization.
DroidSpeak doesn't treat all the layers in the model equally.
So some layers are more important than others.
Well, it focuses on those layers where the similarity is highest.
Because those are the areas where reuse makes the most sense.
Exactly. It's a custom-tailored approach. Finds the best reuse strategy for each AI pair.
Okay, finding the perfect match for maximum efficiency.
Exactly. And the results are really impressive. The research shows significant speed-ups without hurting accuracy.
That's what we like to hear. Now, you mentioned DroidSpeak reuses both the KV cache and the E cache.
Yes.
Just a quick reminder, what are those again?
Of course. The KV cache, like we said, is like a summary of what the AI has learned.
Contains the main takeaway.
Yeah, it's like a cheat sheet for understanding the whole conversation.
Okay, I got it. And the E cache.
That represents the AI's initial way of encoding the text.
It's like the raw ingredients before the AI cooks up an understanding, right?
Yeah. A perfect analogy.
I try. So DroidSpeak combines these caches to make communication faster.
Yes. But remember, we talked about the challenges of blindly reusing everything from the KV cache.
Yeah, like using someone else's notes can sometimes backfire.
Right. DroidSpeak needs to be careful not to sacrifice accuracy for speed.
So how does it avoid that?
One technique it uses is called layer dropping.
Layer dropping. Dramatic.
Well, it analyzes each layer to see how similar the models are.
And then decides whether to reuse or recalculate the information in that layer.
Exactly. It's like a constant check. Do I trust my partner's work or double check it?
Interesting. So some AI pairs might be super compatible and reuse a lot of layers.
And others might be more independent and recalculate more often.
So it's like some are team players and some are lone wolves.
Yeah, I like that.
Each with their own style. But how do researchers actually test all of this?
They put it through rigorous experiments, different model pairs, different data sets.
A real AI boot camp.
Yeah, they really push it to its limits.
And how did DroidSpeak hold up?
It did amazingly well. Across different tasks and pairings, it consistently achieved big speed-ups, sometimes even slightly boosting accuracy.
So it's not just fast, it's also really accurate.
Exactly. And the best part, it's adaptable. The optimal configuration they learn can be generalized to new tasks.
So it's not a one-trick pony. This all sounds really promising. But did the research mention any limitations or challenges?
Well, one thing is that the research mainly focused on models that were based on the same foundation.
Like siblings.
Right. It's not clear how well it would work if the models were more different.
Like if they were distant cousins instead.
Yeah. The closer the relationship, the easier it is to share.
That makes sense. Anything else?
Well, there's also the overhead of actually transferring the cached information between agents.
So even though we're saving time on processing, we're adding some for the data transfer.
But that's a technical challenge that can be addressed as technology improves.
So they're working on optimizing that aspect as well.
Yes, they're exploring better compression techniques and things like that.
It sounds like there's always room for improvement. But beyond these practical challenges, I'm curious,
Yeah.
did this research spark any, philosophical questions?
It did. If we can make AI communication so much faster by reusing information.
Could we do the same for humans?
Exactly. What if we could share our understanding of complex ideas more efficiently?
Instead of explaining everything from scratch every time.
Right. It's like we all have these vast libraries of knowledge in our heads.
But we haven't quite figured out how to share them effectively.
Right. Maybe DroidSpeak can inspire us to think differently about human communication.
Wow, that's a really interesting thought. So we've gone from speeding up AI to pondering the future of human interaction.
It's all connected. That's what's so cool about this research.
It really makes you think. Before we move on, can we do a quick recap of what we've learned?
Sure. DroidSpeak uses that offline profiling to figure out the best reuse strategy for each AI pair.
And then it selectively reuses those KV and E caches to make communication faster.
Without sacrificing accuracy.
And we even touched on those limitations and those philosophical questions.
It's been quite a journey.
It has. Ready to continue.
Absolutely. Let's see what other insights this research has to offer.
Let's do it. Okay, let's dive back into DroidSpeak. Last time we were talking about how there's variation within those AI models.
Right. We've talked about DroidSpeak optimizing communication between different AI agents.
Making those conversations faster.
Exactly. But the research also looked at information reuse within a single AI model.
Right, within one model. Remind me, we're talking about those different layers, right?
Yeah, the different layers of the AI's thinking process. And remember how some layers are more similar between models than others?
Right, like some layers are more universal.
And what's interesting is this variation even exists at the level of individual tokens.
Tokens?
Yeah, remember those are like the basic units of language.
Like words and punctuation.
Exactly, the building blocks the AI uses.
So you're saying different tokens within the same layer can be more or less similar between the base model and the fine-tuned model.
Precisely. It's like even within a single recipe, some steps are more universal than others.
Okay, I'm following. And this is important for DroidSpeak because
it means we can optimize even further.
by being picky about which tokens we reuse.
Exactly. Instead of just reusing a whole layer, we can look at individual tokens.
And the research actually suggests how to do this.
They found some tokens have really high correlation between the base model and the fine-tuned model.
So their representations are almost identical.
Yeah, and those are the best ones to reuse. No need to waste time recalculating.
Makes sense. Save time where you can. But what about tokens with low correlation, where the models have diverged a bit?
Those are the ones where it might be better to recalculate.
To make sure the AI's understanding is on point.
Right. It's all about finding that balance between efficiency and quality.
This is fascinating. It feels like we're peeking into the AI's brain and figuring out how to make it work smarter.
It is pretty cool.
Did the research talk about any other ways DroidSpeak could be used beyond those back-and-forth exchanges?
They did. They started looking at how these principles could apply to more complex situations, like when multiple AI agents are working together.
Oh, wow. So like a team of AIs collaborating on a project.
Exactly. Imagine a group of AI agents working on a big coding project.
Each one handling a different part.
Right. The communication challenges get even bigger in those scenarios.
I can imagine. Trying to keep all those AIs in sync.
But the researchers think DroidSpeak's core ideas could still apply.
Okay, how would that work?
They talked about a hierarchical approach.
Hierarchical?
Yeah, so the agents would first share high-level information.
To get everyone on the same page.
Right. And then they would dive into the specifics as needed.
It's like starting with a rough outline and then adding details.
Exactly.
Mhm.
Makes the process much more efficient.
Did they mention any other strategies for these more complex interactions?
They also talked about dynamic caching mechanisms.
Dynamic caching. Fancy.
Basically, the agents could adjust their reuse strategies on the fly, depending on the task and who they're working with.
So they're learning and adapting their communication style as they go.
Right. Being flexible is key for real-world AI applications.
This is all so mind-blowing. It seems like the possibilities for AI collaboration are endless.
It really does feel that way. This research opens up a whole new world of possibilities.
Well, my brain is certainly full of new ideas after this deep dive. Thanks for taking us on this journey into DroidSpeak.
My pleasure. It's been a great conversation.
And a huge thanks to all our listeners for joining us on this episode of The Deep Dive. We'll be back soon to explore another cutting-edge topic. Until then, stay curious.
Lenny and Jenny in a bright spotlight. Shine with topics rolling like a river tonight. Flow, audience laughter fills the air with delight. Live phones ringing and the mood is right. Ring, spinning tears and cracking, just come on, let it show. Causing cheers, the energies are flowing, don't you know? The night ain't stale with the crowd in stereo. So take a seat, the shoe's about to glow.